Hey everybody, so right now we're going to look at this problem which says that we want to graph the equation 3x plus 6y plus 2z equals 18, and we want to show graphically that the point 2, 1, 3 is a solution. Now we saw that it's really hard to represent this on a piece of paper because that's actually just in 2 dimensions. So what we're going to look at right now is how to graph this in 3 dimensions using 3-dimension software. So we're going to start by, we need to figure out the 3 intercepts for this equation. Reminder, those are the points where the graph's going to cross the x, y, and z axis. If you feel like you remember how to do that, then you can skip this part of the video, but if not, just a reminder that here's our equation, 3x plus 6y plus 2z equals 18, and if we want to find the x-intercept, we're effectively saying that the other two values, the y and the z, are going to be 0. So we're going to set y equal to 0, we're going to set z equal to 0, and that's going to give us the equation 3x equals 18. This is fairly straightforward to solve. We just divide by 3 on both sides, and that gives us the coordinate x equals 6. Now, the other two are solved in the exact same fashion, where instead of setting y and z to 0, we would set x and y, or x and z to 0. Solving through these, we end up with the following. We end up with x equals 6, we get y equals 3, and we get z equals 9. Now the big mistake people have been making with this is that they are treating this as a single coordinate. 6, 3. Yes. 6, 3, 9. But this is wrong. This is not a single coordinate. These are 3 separate coordinates. And so the x coordinate here is really the coordinate 6, 0, 0. And the y coordinate here is the coordinate 0, 3, 0. And the z coordinate is the coordinate 0, 0, 9. So we found these 3 coordinates by finding the intercepts by setting the variables in this equation equal to 0. So let's start by graphing these 3 coordinates. We're going to do that in this software called GeoGebra. Okay, so here's our XYZ coordinate plane. You can move the plane around by clicking with the little pointer and just dragging your mouse to side. So I would spend like a minute or two just seeing that you know how to do that. You can also zoom in and zoom out by using 2 fingers and pushing forward or pushing backwards, kind of like on an iPhone or something. So our points that we wanted to graph were the points 6, 0, 0. You can hit enter after you type it in. The point 0, 3, 0. Hit enter, and then the point 0, 0, 9. And notice that last point we can't see in our graph. So, there, it clicked in for us. But if not, we can always zoom in and zoom out, so we can actually see that last point there. Okay? So these are our 3 points, and these 3 points are going to define our solutions, but we actually need to put it in. There are 2 different ways to do this. I personally really like the way that just makes a plane. So we can go to this little thing up here that says Tools. You can see where my mouse is pointing to. And we can click on that, and then there's this basic tool, which is a plane through 3 points. So in order to do this, you click plane through 3 points. We click the 3 points we want to make a plane through, and out pops our plane. Now, one thing that's weird, if you look at the mouse right now, it has this little cross right here. It is still in plane through 3 points mode. So what we want to do when we're done with our plane is we want to go back to the little pointer icon here and click that. And that way we can move our plane around. And you can see right here we can actually drag our plane around. And there you can kind of get like a perpendicular view of your plane and all that kind of stuff. Now this way is useful, but one thing that's annoying is it doesn't kind of show us how this looks on our axes. So I also personally like to really add in a line when we do this. So if you scroll down through these basic tools, you can see here that there's one that just adds a segment. And so I'm going to click on that one. I'm going to click the segment tool. And now it says select 2 points or positions. So I'm going to select A and B. And now it's still in my segment selecting tool, so I'm going to select B and C. And then I'm going to select C and A. And now you can see, I'll click out by clicking the mouse. Right now, we kind of have these three lines that help define our actual plane. And something that's weird is like you can kind of see that there's like a dashed line there. The dashed line is how you know that a line is behind a plane. And a solid line means it's in front of the plane. So look at the axes down there. If you look at the XY axes right here, here they're dashed. Here it's dashed, and here it's dashed. That's because they are behind the plane right here. And if we flip this around, we can see that the other sides, now this part's dashed, and this part is dashed because they're now behind the plane because of how we changed. So it's trying to give you a little bit of extra information about where this plane is. And you can see here, none of the lines are dashed because none of them are behind the plane because of how we've oriented. So, so we have our plane, we have our lines that are defining our plane. The last thing we need to do is put in our other point we wanted to check. And the point that I believe it asked us to check was 2, 1, 3. So we can go back to this, we go down to a little bit of space, we plug in the point 2, 1, 3, and there it is. And it's a little hard to see, but one of the nice things is we can change our orientation. And we can see right there that point D is directly in that plane. It's in that solution. And that's it. Now, if you don't like having the plane shown right now,
I had a pee-pee accident, and the couch is soaked of pee-pee too.